So we know it's broken. We can go back to Jazzy. Let's get out of the bin folder. We're in our branch already. So we knew at this point is like kind of like shooting in the dark. I mean, you can see the tree. I just dumped out the tree. There's like 2,986 directories in this project. Like, it's not a huge project, but at the same time, like, I don't know any of all this stuff that's going on. I mean, the reason it's that big even is because of all those submodule imports. So let's go check out lib, because that's where the code is really. So if we do tree in here, so there's 16 directories, 54 files, right? So that's pretty small. And so we can take a look at the structure of things. So there's Jazzy, then there's some, like the main source files look like they exist there. Then there's this themes directory, which I'm guessing is like themes for how the docs get displayed. There's an Apple one, there's a full width one, and that looks like that's about it. So one thing that's interesting is this. There's a file called docset builder. Let's go take a look at docset builder. So docset builder, Jazzy doc builder, class docset builder. Looks like it is some class that takes some generated docs directory, a source module, sets up some things, knows about the generated docs directory, the output directory, knows about contents, resource documents, etc. This looks like the main entry point for this class, which looks to, you know, if docs_dir exists, remove the tree, copies the docs, copies the icon, writes a plist, creates the index, and creates an archive. Let's go see what create index does. This is looking promising. So we can see create index here actually references that same docset DSIDX file. We can see it's opening a SQLite 3 database. It's creating the table the way that it said in the dash documentation. It's setting up a uniqueness constraint on that table to make sure you don't get duplicates. And then it looks like this is where it's actually populated. So it's doing whatever source module is, calling all declarations on that. It's then selecting type for each of those. And then for each, it's running this block, which is inserting or ignore into search index with this name and whatever the values are, which are these things here. So that leaves us with doc name, doc type, dot dash type, and doc URL. So at this point, my next guess is that we should probably just go jump and see, or I'll do a search to see where dash type is actually referenced and defined. Hopefully there's not a ton of places, and hopefully there's really only one place we have to go look. Looks like there's 14 references complete. Looks like there's a bunch of mustache references, which are, mustache is a templating language, so I'm pretty sure there's no real logic inside there. So we should just be able to look at these 6. So it looks like this source declaration type RB file is what defines it. Do these other ones have any implication? They're part of doc builder. Doc dash type. Some doc type. are just normal use cases? I think we probably care about this. Let me get rid of these extra windows since we care about being here where this dash type method is defined. So this dash type method checks if type exists and type symbol dash, subscript symbol dash, then it will return type subscript symbol dash. Looks like it also has a name over here, which is type and type Jazzy. Where's type? So there's initialize, kind, and type. So what's in types? Types is defined in the same file. So looks like some sort of hash where they have a key that maps to another hash, and that hash has a key, two keys. One's Jazzy, one is dash. And those are mapping to the different types like class, extension, unexposed, constant, enum, etc. So this is making me think we're in the right place. Let's go back to docset builder and let's just add some output so we can get a better idea of what's going on. I'm a fan of when I'm creating output that I know I want to get rid of later, I always throw my name in as a prefix. This makes it super easy for me to jump back to it in the code without having to know exactly where in the code I left it, because I can use tools to search for it pretty easily. It also makes searching the output, if it's intermixed with a bunch of logs or things like that, to easily jump to it. So in this case, let's output the doc name. We'll do that, doc name.inspect. We'll put string doc type dot dash type type dot dash type. Oops. What else? I guess we could put the URL just for completeness. I don't think we really care about the URL in this case, but can't hurt. The reason I throw inspect in these cases too is because if it's null, I want to actually see that it's null. I don't want to see that it's an empty string. And because there's going to be a bunch of these, let's print a little separator. Okay, so let's jump back to constraid. Let's go back to the root of the project. And Jazzy. Okay, let's run our local Jazzy again. And this time we should see the output from the put statements that I just added. All right, so we can see right here the actual dash type being nil. Oops, this just got rebuilt and it refreshed itself. We can close this right now since we can see it right here. So we can see the dash type's nil for these. If you go up, you can see where it's no longer nil. This is a global. Here's the name of the global. This is dash type global, blah, 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 right? So we know where dash type is coming from. Let's see if we can go just define our own, given that how would we define our own? Let's try to output one more thing. The thing that I'm thinking is I don't know what the key is, the value of the key is in our case. If we go back to Jazzy and we look at the code from above, all these things have these keys like document.markdown, source_kitten.source.lang.obc, declare, unexposed, etc., etc., etc. And so those keys, if we go back up here where the mapping happens with type, which is what we're printing out, is dash type right now. So dash type is type, if that exists, and type dash. So I'm wondering if we look at the type, then we can see what the kind is, which is the key. Because we need to know what the kind is. So let's take it one step further in terms of our information that we're putting out. Let's put Drew doc type. And let's see what we get when we do this. Just doc.type.inspect. What kind of information do we get when we do this? Ah, cool. So now we see that these are kind of overview. And so the kind overview is the key that's used in that type map. If we go back to Jazzy, so we go back to the source declaration type class, there's this types map that we were looking at, and here is how it figures out what the type is, and dash type is a child of that type object. So kind is the key that is used for that. So in our case, we know that kind is overview. So let's go look at types. Let's do types. So just scanning through this, let's see how big this is. I'm scanning through this to see if I see overview referenced anywhere. It looked like it's split into two sections. That top section was Objective-C. This section has a comment saying it's Swift. So I don't see overview anywhere yet. And that's the end of it. Let's search for overview. So it's referenced here where it constructs a new type with the kind overview, and then it's referenced here in this name controlled manually use case. So my assumption now is the reason that we're getting null is because it's trying, when we call dash type up here, type is null, and the reason type is null is because we're saying, hey, types map, give me the thing that's identified as overview, and it says, hey, there is nothing that's identified by overview, so you get nil back. And then when we call dash type, it says, hey, if type exists, but it doesn't because it's nil, so it short circuits and we get nil back. So what we need to do, I'm guessing, is define an overview type. So let's try to replicate our own overview type. So let's just add our own overview type. So this is, a lot of people would be like, well, shouldn't you be writing tests? Shouldn't you be doing TDD? And no, I mean, the answer is yes, you should do TDD, but right now, like, I'm not even in a development mindset. I'm in like an exploration mindset, and I'm doing, the coding I'm doing is things to, you know, verify things and kind of discover how the thing actually works. So right now I'm adding a new section here with overview. The reason I'm doing that is because my theory is that if I, Maverick, come here, Maverick. So if I do that, then, and I define Jazzy as a type, or not Jazzy, but dash as a type, then it'll potentially work. So let's figure out what type. So if we, so in that documentation for dash, they have all the supported entry types. And section, I read through all of these, and section was the only one that seemed like it fit. Everything else seems like it has a direct translation to something in code, like a hook, a keyword, a method, etc., or to a guide, which in my mind is a different thing. And this seems like section is pretty fitting, so let's try section. And then, so the Jazzy case is interesting because we could change it to section, but I'm guessing the reason that's going to be interesting is because this will change the behavior in terms of other things other than dash in the Jazzy case, I'm guessing, right? Because the docset use case, the dash docset use case uses this, but I don't know what uses Jazzy. I'm guessing the other case, which is just producing normal Jazzy documentation, uses this. And before, that value was nil. So, and it looks like that key is used in name, where it does basically the same thing as dash type. It says if the type exists and type has Jazzy, then return whatever that value is. And the other place it's used is if type exists and type has a URL, then do that, or type Jazzy if it doesn't have URL. Interesting. So, and then if it didn't have URL or Jazzy, then it would be nil, or it didn't have type. So my guess, and then all of these have Jazzy values. Okay, so if we want to keep it behaving the same way it currently does for Jazzy, we should be able to just replace this with nil, I think, based on reading the code above. And then dash will now input a value of section. Let's give that a shot and see what the results are. So let's go back to constraid. Let's run our Jazzy. Uh-oh. We clearly broke something. What did we break? No method error. Plural name, undefined method, pluralize. That seems strange. Do we have a typo or something? Type RB 39. 30. What? First of all, let's comment out our code that we just added and make sure that that is the problem. And that is the problem. So there's something wrong with the code. What is wrong with this code? Is it the nil for the Jazzy use case? Is that? I'm pretty sure it's nil in Ruby. I've been doing a lot of Swift lately, but I'm pretty sure it's nil. I just copy and pasted that line from the line above, and the only thing I changed was nil. Let's change this to section as well. Maybe it doesn't like the nil. Maybe the nil puts it down some crazy path that I don't understand yet. So that worked. Interesting. So the dash type is now section, which is a good sign. But our URLs, are those different? Yeah, our URLs are different, which is not good. Because it's prefixing, it looks like it's prefixing those URLs that used to be just extensions.html or functions.html. It's now prefixing those with the word sections. Which I'm guessing is a side effect of Jazzy section being a thing. So maybe we'll have to dive into that further. Yeah. I don't really understand that error message. Foo equals nil. Yeah, it's nil. It's definitely nil in Ruby. Why? Let's make this nil again. Let's go run our test again. Let me grab something to drink. Oh, where's my drink? All right, got me some passion fruit LaCroix. Couldn't find my drink, so I had to go get a new one. Oh yeah. Gotta love the LaCroix. All right. What do we got going on here? Undefined method pluralized for nil. Okay. So pluralize is getting called on nil, and I'm guessing that's happening as a side effect of that Jazzy value coming back. Let's go see what line that is again. Let's go. That's on type, line 39. So let's go check out that more closely. 39. Okay. What did this used to do before? Because type was nil before. So now type is not nil. So this is getting called. We need to walk this call path. Because, so my assumption at this point is, well, we know what's happening from the error. Name is nil, and pluralize is getting called on nil. We know that from the backtrace that we saw in the output. We can go back and see that again. So we can see right here, it says type 39, plural name, undefined method pluralize for nil. So plural name is getting called, or sorry, pluralize is getting called on nil inside the plural name method. And it gives us the line number. And this is just the call path that it took. And so this is going to be important. This call path that it took is going to be important in a second, because what we need to do, or what my assumption is that before, if we go back to Jazzy, before type was nil. Like, I'm just comparing the differences since the way it was before code-wise and what was happening execution-wise to what it looks like exists and is happening now. So the only difference is that before type was nil, right? So name would still be returning nil because it would short circuit this. So then the next question in my head was, well, how did we not run into this before? And so my assumption is that the reason we didn't run into this before is because somewhere earlier in the call stack, there's a check for whether type exists or not. And based on type existing or not, it is then deciding whether or not to call plural name or not. So I think what we need to do is walk backwards in the call stack in this particular path and see if we can find where that conditional is that checks for type and maybe adjust that. So let's figure that out. So the place right before this where this gets called is source kitten 88. So if we go to Jazzy, let's go source kitten RB 88. So not quite sure. Dog type equals type. So it looks like there's this group type categories method. And if we go back, we can see right here, we're in that path, right? That's group type categories, which has some map, which has a block inside of it, which then calls that plural name thing, right? So we're in the right place. We just need to kind of understand what is going on a little bit better. I'm not quite sure what all of this does. So group type categories. So it takes all the docs, gets type category prefix. It says group is equal to source declaration type dot all. So it's mapping each of those types. For each of those types, it then calls docs partition. And looks like it partitions them based on the doc types being equal. And then it partitions them, I guess, into children and docs, whatever that means. And then it makes a group given a set of children and the type category prefix plus the type plural name. And plural URL name. So we may run into the same issue in plural URL name. I'm not quite sure. I'm guessing that it has to do with this. Maybe? Let's put some logging here. Let's try to figure out more about type in the original use case. So let's print out the type, actually. Let's do inside group type categories. And let's do type dot inspect. And we'll put a separator. And let's go back. Docset builder. We can leave all that. Let's go to types wherever we had types. That was in a separate file. That was in this file. Types. Let's comment this guy out. And the reason I'm doing that is because I want to see in that section of the code, I want to understand better what the type values look like. Okay. Does it happen before this? It does. Okay, here we go. So inside group type categories, Jazzy, source declaration type, kind, this thing type Jazzy, so on and so forth. And so I think so let's walk through these. There's not that many of them. I'm guessing that we never ran into this issue before because this thing that produces this list of these types that it's processing in here thing that's producing this list of types, I'm guessing only originally is producing the non-null types. Because remember, it didn't used to have a type before, right? We're giving it a type. And I bet if we go back and add this in, and then go back and run it again, we'll see, I'm guessing, that our thing is a type and it has Jazzy as nil. See, whoa, sorry about that. So right here, we can see, here's our type, and it has a kind of overview. And the thing you'll notice is that none of the ones we looked at before have a kind of overview. It just wasn't included. And I believe the reason it wasn't included was because type itself was completely nil before. So I think it wasn't even included as part of the set that is returned. So that's my assumption right now. If we go back to source kitten, which means so docs partition, so yeah, so type all right here, source declaration type, which is the class we were looking at before, has a class level method called all, and that's then mapping over all of those. So in order to try and keep changes centralized and behavior the same, this is going through each of the types. So all is going through each of the types. And mapping them into type objects based on keys, which are actually kinds. So it's actually going through and constructing a type for every one of these entries in this type map down below. Let's just try, let's look up something real quick. Let's look up in Ruby array exclude. Is it exclude filter? Enumerable filter. What is the freaking method call in Ruby land? Reject. Reject. Returns an array for all elements of the enumerable for which the block returns false. What I'm looking for, this is a side effect of being a friggin' polyglot, is you just can't keep everything in your head. So despite the many years that I've done Ruby, even when you take breaks for a couple months to do other languages, you tend to have to look things up more frequently in documentation. Like right now, I probably just want to use select, I think. Because this will return an array containing all the elements of the enum, which the block returns true. And that's really what I want, and I'll just invert the conditional probably, because what I want to do is take this and change it so that I'm guessing this won't work in the long run, but I still want to see what's going to happen if we do this behavior-wise. Because my thinking is it would be ideal if we could centralize changes here and keep behavior the same, but still have it function the way we want for our use case. And so in order to do that, we would need to exclude the overview type that I added. So that's what my thought was that we could do select and we could say we want all the ones where it's not true or where it is true. It's going to select the ones where it is true. So we want ones where the key is not equal to overview, because overview is the name of the key that we added that has Jazzy nil. So this should exclude the overview completely from this result set, keeping the behavior in terms of this method the same, or as if overview was never added, which could solve the problem that we are seeing, but could also introduce another problem where maybe because it's not part of this list, maybe it doesn't actually get processed appropriately, and therefore we don't end up fixing our problem in the database. But let's try it anyways to see what happens. Oh crap, what did I do? I screwed something up big time. Syntax require, syntax error, unexpected pipe. Unexpected pipe. What is wrong with my syntax? What the hell is wrong with my syntax? Dash. Select. Num. Something. What did I screw up with my syntax? Does it not like the chaining of it? Oh, it does not like the parentheses of it. What the? It doesn't like the parentheses. It's doing a thing. Looks like it completed. Looks like our output still shows our sections, and the URLs look like they're correct now. So maybe that fixed it. Maybe that does exactly what we want. Quite possibly. All right, let's look at the docs and the doc set that was created. Let's go look at the actual database contents to make sure that's good. What did I open? All right, let's see. What's at the bottom? Oh, sweet. So we have section types in here now. And you'll notice we have no null types in our doc set index any longer. So it seems like a good thing. Seems like it's processing our docs appropriately. It's not crashing out because of our introduction of nil and how that behaves. It is a little janky to exclude that magic thing, but that's fine for right now. We can approach figuring out how to do that in a different way later once we know this is the correct solution. I guess the next thing, let's save this. We can delete that because we have Git. No need to keep comments lying around like that. Guess we should just run the tests. Make sure at this point we didn't break anything else. My guess is we somehow broke something else, but the test will tell us. Hopefully, assuming that there's decent test coverage. Let's run the test again. Sit for a little bit. Enjoy my LaCroix. A little bit of LaCroix. Uh-oh. 26 failures. That kind of sucks. This is what it is, though. I wonder if those failures are caused by the output. Because you notice in the output above that those are indicated like a diff. So let's go remove. Oops. Let's go remove all of my put statements that were there for debugging. Let's delete these. And let's go to this guy. Let's delete all these. Oops. All right. Got rid of all my print statements. Let's try that again. Maybe we get lucky. Maybe it was just the output. No, not so lucky. All right, now we're down to 24 errors. Or I think 24 errors. I mean, these could be failures that are justifiable good failures. Like, could be that the test results that it's comparing it to were actually wrong. See, bacon error, file comparison error. Box categories HTML. So with my changes, these HTML files are different, and this docset DSIDX CSV is different. That one probably should be different because that's what we were changing. These maybe should be different. I'm not quite sure. Let's see if we can start. So here's the top. I create a new window so I can keep this open in this window. So categories, HTML, classes, constants, enums, protocols, type definitions. These are all what we consider sections. So that could have something to do with why those changed. Although it looks like categories and classes and protocols, those also changed, and constants and enums, type definitions. So let's see. Create docs for Objective-C projects. So that's the Jazzy kit doc set. How did all of these things fail? So docs categories, HTML, is different by it having an additional A record. It's got an additional anchor tag that has Apple Ref obc section categories. All right. All these file comparisons fail for the same reason. They all have this additional Apple Ref thing going on. Apple Ref. Integration specs, documents. So I don't really know if this is correct or not. Doesn't look super harmful, but you never know. Let's try to, where was that? Let's go look at that again. It's in specs, integration specs, document, CS before, nope. Specs, integration spec, specs, integration spec, MISC Jazzy features after, MISC Jazzy features after docs, other structs. Oops. I'm curious. Where that is actually present. structs apple ref. So this is in task name container. I'm looking for a keyword I can use to search in the DOM. See if I can find it in the DOM. Looks like task name container is it. Because I'm interested to see how this impacts the actual outputted HTML. Task name container. So they're not actually visible. Because it's size 0, 0 in the CSS. So visually, it's not actually impactful. So I'm betting that that is actually a necessity, and that normally, let's say we were to look at something that you know, has like actual docs on something. I'm betting that that thing is a reference for each of these individual items that that Apple depends on in some case, or Dash depends on. I'm guessing Apple, maybe it's for the Apple Docs reader or something, because all these other items have it. Because those didn't show up as part of the diff. I mean, they're there for these other cases. So I think it's okay that they're actually now there for the what we were calling sections. So let's go back and see if we see any other diffs other than the adding of the Apple refs for those sections. So here's the other diff, which is the CSV. And this is showing the addition of the section type. Strange that this last entry has quotes around them, but it had quotes around them before too. So I don't think that's a problem, or it's existing behavior. It's strange that it's not consistent, but this is result diff that we expected as well. So that looks like the extent of it.